12. So straight away, cyclohexane can't be an isomer of an alkane because the corresponding alkane, thank you Sarah, it will be C6H14. Okay, but it gets the name hexane because it has all single bonds between the carbons. So this, when we get to it, is a derivative of the next homologous series of an alkene. So this guy down here, the 2,2,4 trimethyl pentane. So it doesn't matter if you went from left or right, this particular carbon is doing its numbering from the left, because you always go with put your branches on the lowest numbers. And it's really important that the part that's in the circle, where you have expanded and shown your H's, the single bonds, that keep maintaining that. Okay, you can, there are instances, and you may see them in some books, where they'd actually write this as the branch, but it depends on how the SEC ask the question, so I avoid this and always show every bond. Is there any questions on those? We're happy? We take silence as a yes. So then we go to look at this. So is cyclohexane aliphatic or aromatic? Come on guys, I know it's Friday morning, but you can do this. Thank you so much, Miles. It is aliphatic because it doesn't have the benzene ring in it. This is an old school version of benzene before they understood how its bonding actually was. This is the new school version of it. But essentially benzene is C6H6 in terms of its formula, whereas cyclohexane we've said is C6H12. So this is a non-benzene ring. In some instances, so in my past life when I was doing small molecule drug discovery, drug development, you'd have a ginormous formula and you don't want to be showing all of these bonds in your formula. So what they do, this is called skeletal, and all you're showing is where the carbons are. So if you were doing something like hexane with 6 carbons, you would draw it 1, 2, 3, so 1, 2, 3, 4, 5 and 6. So each kind of point, so point here, point here, point here, point here, point here, and point here. These are all where the carbons are, and you're able to work out, if you had to, how many hydrogens would be attached. The SEC will accept versions of this as opposed to this, because it is chemistry and it means the same thing. But if you have a big ginormous molecular compound as a drug, you don't want to be showing all of your hydrogen bonds, so they use this skeletal setup to do that. Okay, so then we asked you to draw some structures. So this was the 2-methyl propane, and this is the 2-methyl pentane. So, sorry, as long as you make sure so in the first one, the thing in the brackets was this. And it doesn't matter if you put it above or below the C. And in the second one, the thing in the brackets was this. So you just make sure you have, for the prop, 3 carbons and a methyl group coming off the middle carbon. And in the pent, you have a 5-carbon chain, and you can put it off this one if you wish. You can start your numbering from the left. I just started it from the right. And as long as it's off the second carbon, the SEC will be happy. Other questions? Because I can see wrinkles from here. Okay, so the next two then was a 2,3 dimethyl propane. So as long as off second and third carbon you had a methyl group off each, and you had, was it Canton group? No, it was a pent. So as long as you have 5 carbons in your main chain and a methyl group coming off the second and third carbon from the right or the left, that is okay. And the last one was 2,3 dimethyl butane. Okay, forgot a H here. So that's one group, that's the second. Okay, then asked to draw from names. So it was a bute, 4 carbons, and then a methyl group of carbon 2. Second one was dimethyl bute, so 4 carbons, and this time methyl of 2 and of 3. So I've offset them here. It doesn't matter if they're both on the same side or on opposite sides. It has to do cyclohexane, which we've done already, and then it had 4 ethyl 2,2 dimethyl heptane. So 7 carbons in your main chain of carbon 2, a methyl group on either side, and of carbon 4, an ethyl group. Okay, so just looking now at these guys here, are these actually isomers of each other? So thumb up if you think it is, thumb down if you think it's not. Okay, good job. Reason being, this has 3 carbons in a main chain, whichever way you decide you're going to look at it. This is only 1 branch, whereas this has 2. They're not isomers. Alrighty, so alrighty, so today we're just going to, it's a relatively short lesson, you'll be delighted. You may remember this from something we've done earlier, but essentially we're going to look at the reactivity of alkanes. So if we take ethene as our first one, I need to close the blind now. So can you remember when we in Form 4 we had other ways of describing bonding rather than single and double? Can you remember the other way that we could describe these bonds?
Sigma pi.
Yeah.
Sigma and pi.
So does this what does this have? So if you have to describe the bonding in ethane, does it have how many sigma bonds, how many pi bonds does it have?
It just has sigma because it's alkane, doesn't it?
It is just has sigma because it's an alkane. So we've said sigma is the head-on overlap of atomic orbitals. So again, just to remind you, we don't go into it at Leaving Cert in any type of detail at all. But essentially, you have orbitals in carbon which had the outer shell electrons. So carbon is what? 1s2, 2s2, 2p2. So what you're getting is I don't really want to get into it, but it is called sp hybridization. We don't do it, but what it is that the orbitals kind of interact with each other so that they can share electrons, and then this is how we represent the sigma bond. Sorry, wrong Greek letter. And they're similarly going to be coming off each carbon. They will all be sigma bonded. So the orbitals overlap head on, and that's where they can share their electrons and they can be found. Now, do you think that the alkanes would be very reactive? And this is possibly a question you can't answer because you don't know enough stuff yet. But do you know what we do with alkanes? We're going to go on to crude oil and its fractionation eventually. But do you know some of the things that we do with alkanes?
Make petrol.
We make petrol. So what is it that petrol does in a car engine?
Combust.
It combusts. So because these are all sigma bonds, they are all pretty much, it's very unreactive because the electrons are happy. They're in shared pairs. The carbon has a full outer shell of 8 electrons. Hydrogen has a full outer shell of 2 electrons. So this is really, really happy. It doesn't need to get electrons from somewhere else. So because it's got these sigma bonds between it, it is pretty much unreactive. But the only thing it will do is that it will actually combust for us. So I'm going to change my share and show you this. Okay, that music is gonna annoy. Alrighty, so if we were in before Christmas, did you guys get to do the methane bubbles? Is there anyone in the room that we did this with? So that's just a pure example of combustion of methane. So we literally fill the water with washing up liquid. We put a rubber tube into it with the methane coming out of the gas taps. The bubbles literally fill with the methane gas, and we set them on fire. Good fun, but that's essentially showing you what the methane is doing. So we're looking at the top of page 168 for me. And we're just going to talk a little bit about the reactivity and go back to doing some equations again. So the alkanes themselves are unreactive, and that's because they are saturated compounds. They've only single bonds present, and if you want to put in just the sigma to remind yourself, you can. But what they will do is they will undergo combustion. Now, can I use the FOCDW to help me write my combustion equations? Can anyone figure out what the letters are supposed to be? No, it's for,
fuel, oxygen, carbon dioxide, and water.
yeah. So it's always going to be the same. So it can be an alkane, but it can be any fuel. And when we go to the thermochemistry part, we will be having to write what are called heat of combustion equations. So you will be using your FOCDW. So you won't ever have to do the word equation. You will always be doing it in terms of formula. So do you think you could try for me to put the methane plus oxygen and goes to carbon dioxide and water into a formula equation? So for Gerald and Charlie, you write out your formulas for each thing. So formula for methane plus formula for oxygen, arrow to the right, carbon dioxide formula, water formula. You then go back onto your left hand side and you are going to leave balancing oxygen onto last. And what you want to look at is, do I have the same number of carbons on both sides? So CO2 plus H2O. So I'm going to look here on my left hand side. I have one carbon here. I have one carbon here. I don't need to do anything with them. So in the past, when we were learning how to balance equations, this is the way we did it. So we wrote everything we had and we put them in little packages. And if you have to make any additions, you have to make the addition of the whole package. So over here on this left hand side I have 4 hydrogens. Over here on this right side I only have 2. So the only way I can get 2 more hydrogens on the right hand side is to add it in its package. So my C's are now balanced, my H's are now balanced, and now I look at my O's. So over here on this right hand side I have 1, 2, 3, 4 O's. Over here on this left hand side I have 2 O's. The only way I can get 4 O's is to add another package. So it should balance as a 2 and a 2 here. Okay, underneath that you have a space that says repeat in words and balanced formula equations for C3, C5 and C7. So go mad, people. And if you have questions, please ask. Excuse me. What's my formula for propane? C3 what?
C3H8.
Thank you so much. So you can, if you need to, write out your bubble. Okay, so Gerald and Charlie, if you can't do it without, by just looking at the formula, then you can do it using the bubbles. So I started with these guys. I have to have 3 carbons on my right hand side, so I need to have 3 CO2s. I have to have 8 carbons on my right hand side, so I have to make 4 waters. I then count up my oxygens to give me 10. I already have 2, but to get 10 oxygen it must mean I have 5 O2. So if in doubt what to do with the oxygen on this left hand side, if you have 10 on the right and 2 on the left, you can write it like this, and you can even leave it as 10 divided by 2 O2. The SEC will accept that. So formula for pentane.
C5 page 12.
Thank you so much. Okay, so I have 5 carbons this side. I have to have 5 carbons this side. I have 12 carbons this side, or hydrogens on my left. I have to have 6 over here. I then work out how many oxygens I have. So I have 5 by 2 is 10 O here, plus 6 by 1 is 6 O here. So I have 16 oxygens, which is 16 over 2, which is the same as saying 8. And in our last one, C7. So C7 is a hept. So what's my hept formula?
C7H16.
Correct. So C7H16. So I have to have 7 carbons on this side. I have to turn this into 8H2O to match 16, and then I work out how many oxygens I have. So I have 7 by 2 here is 14, and I have 8 by 1 is 8. 8 plus 14 is 22. So it's 22 over 2 oxygens, which is the same as 11 O2. Okay, so hopefully you're all okay at doing those at this point. So for the last bit of this lesson, and we can decide on what time we're going to come back, I want you to have a look at these questions now for me. So 6A part 1 and part 4, not 1, 2, 4. 6E, 6B part I and part II, and 6A. So if you want to turn off cameras and do whatever or leave, but if you want to come back, we'll say come back at about 22. Does that seem okay? And we'll just check through them for you. Thank you, Gerald. Okay, so the 2019 was relatively straightforward. The things they had in common, thank you Harriet, were structural isomers. The 3 formulas, first one pentane, second 2-methylbutane, and the third 2,2-dimethylpropane. In the 2016 octane you had to draw, so that's 8 carbons in your main chain, filled everything else with hydrogen. You had to do the 2,2,4-trimethylpentane, and this is one that they will ask when we actually get into the fuels part of this properly. So again, I would recommend that you are showing your side groups expanded. And over here you had to draw ethyl benzene, so that is a benzene ring with an ethyl group attached to it. Thumbs up, thumbs down, thumbs sideways.
On the questions, I don't know if it's meant to be.
Say it again.
Your screen is on the questions. I don't know if it's meant to be on the
Sorry. Thank you. They're the pictures. Okay, they will accept this version up the top. I personally would never draw it. This is what benzene looks like, so we'll try stick to this as much as possible. Okay, it doesn't matter where you put the ethyl group, you can put it at any of these points. We don't go into the naming of aromatics. Okay, so that was the 2016. The 2014 was a little bit more complicated in terms of there was just more stuff to it. So name the homologous series as the alkanes, draw the structural formula of propane. This would be what we were teaching with. It then gave you the protein, prop and bute have their boiling points, and explain why propane has a lower boiling point. So the language that we've used in our explanation, fewer electrons, it'll have a smaller molecular mass, and therefore it has more weaker van der Waals. It then asked you for a definition of structural isomers, so same molecular formula, different structural formulas. It asked you to draw the structural formula of an isomer of butane. There is only one, and this one down here there's 2. So it would be the 2-methylprop here, or it will be the... Is this the same thing? Yeah, it's the same thing. It's just drawn differently. So this would be the tick over here is the one we would have used. Okay, so I'm hoping up here now that you're using the right language for the part B and that you're happy with what that means. Less electrons, smaller molecule, less weaker van der Waals. Okay, so happiness is We need to come back. So for the 2013, I was looking for B. So give the systematic name for A and B. So that was pentane and 2-methylbutane. It asked explain the term isomerization. We technically haven't done that yet, so that's okay. Draw the structural formula of another isomer of A and B. So the only one that was left was the 2,2-dimethyl propane. So this would be the one that you should have drawn. Okay, so different structural formula, same molecular formula. Okay, and then in the last one was the 2010, and it was named the 3 molecules. So hept, cyclohexane, and methylbenzene. So are we happy or sad or middle of the road? Thumbs up, thumbs down. Thank you, Sarah. Thank you, ladies at the top. Thank you, Hannah. Okay, thank you, Mikey. Okay, so that is it. The homework is pinged already. So you can be free, and we shall see you on Monday. Happy weekend.
Thanks.
Thank you.
Thanks, miss.
Thank you.
Thank you.
Thank you.
Bye.
Thank you.